Good evening everyone. Today we will be learning about micro operations. We have already learned that these low-level instructions help us to perform complex instructions. In every execution of complex instructions, it contains each instruction cycle. Similarly, each instruction cycle consists of smaller units which has 4 components: fetch, indirect, execute and interrupt cycle. These cycles involves processor register in each steps. These steps are commonly called as micro operations. You can understand the micro operations in this pictorial diagram. Every process execution consists of instruction cycle, and every instruction cycle consists of 4 components, and each component has a micro operation. There are commonly 4 types of micro operations: arithmetic, logical, shift and register. Now let us understand arithmetic micro operations in detail. The operations involved are addition, subtraction, incrementation, decrement, shift. Addition of two binary numbers of two registers is stored in another register. Subtraction of two binary numbers is stored in another register. The ones complement of binary bits in register is transferred to the same register. The twos complement is stored in the same register. Subtraction is represented using twos complement, where the addition is performed using the twos complement of the negated binary bits. Increment is basically adding 1 bit binary number. Decrement is subtracting the 1 bit binary number. Now let us understand the basics of addition and subtraction. This truth table represents the addition of two binary bits and subtraction of two binary bits. Now let us understand the addition of two binary bits of each register. This represents the actual addition of binary bits of the register. Since it is binary addition, we must subtract the base number from the binary addition. Due to the subtraction of the previous binary bit, we receive the carryover next binary bit. And now we have finally obtained the final answer of addition of binary bits in the register. Now let us understand how subtraction of binary bits is done. The first step is we have to negate the digits having the negative sign before the register. Negation is nothing but 1's complement, where zeros are converted to 1 and 1 are converted to 0. Now we have to convert the 1's complement to 2's complement by adding 1. This equation R1 minus R2 can also be written as R1 plus negation of R2. We know that negation of R2 is nothing but 2's complement. In order to obtain the final result of R1 minus R2, now we add the values of R1 and 2's complement of R2. Now let us understand increment and decrement operation. Increment is adding the bit 1, whereas decrement is subtracting the bit 1. Now let us understand shift or micro operation. Under shift micro operation, there are 3 types: logical shift, arithmetic shift and circular shift. Now let us understand logical shift left. The binary bits in a register consist of two common bits, MSB and LSB. MSB is known as the most significant bit and LSB is known as least significant bit. Under logical shift left, the bits are moved towards the left direction and MSB is discarded. Under LSB, the new bit 0 is inserted. In case of logical shift right, the LSB is discarded and new MSB 0 is inserted and the binary bits are moved towards the right. This is the symbolic representation of logical shift right. Now let us understand arithmetic shift left. Remember that the signed binary numbers is always started with binary bit 1, which represents that it is a negative value. Arithmetic shift left is same as logical shift left, whereas arithmetic shift right is not same as logical shift right. Here in order to preserve the assigned bit number, we repeat the MSB of the binary bits. Now let us understand circular shift. In case of circular shift left, the MSB is replaced with LSB, whereas in case of circular shift right, LSB is replaced with MSB. So friends, we shall be learning about arithmetic shift logical unit in the next session. Till then, stay tuned. Thank you.